So if you know permutation, if you know some combination S, you can easily work out, or you can write down. There no. So how many types of interactions are there? At least I'm saying how many types of interaction. Sir, what do you mean by type? You look at the interaction between 1 and 2. Is it similar to the interaction between 1 and 2 is similar to that between 1 and 8? Definitely. Look at the interaction between 1, 2, 1, 8 and 1, 4 will be same, no? Look at the interaction between 1, 2 and 1, 3. They're different. 1, 3 will become diagonal. Similar, the interaction between 1, 2, 1, 3 and 1, 6. Compare all three. All three are different, no? So 1, 2, the interaction between 1, 2, 1, 3 and 1, 6. They are different. So like that, how many types of interactions are there here? The side, diagonal, and diagonally opposite corner. So these are the three types of interactions are there. So the total interaction potential will be interaction due to each side. Don't say face, better say like a interaction due to each side. Or edge, anything you can prefer. This is one thing. Next, interaction due to diagonal. Plus interaction due to diagonally opposite corner. I think I'll classify the interactions here. Due to side, how many are there? How many sides will come? A cube, how many sides will have? 12. 1, 2, 2, 3, 3, 4, that one in each face. So you can look at that. So 12 are there. So 12 into K, Q minus Q, L. And then we'll go for diagonal. So how many diagonals it will have here? I think it'll also be 12. No? For each face, there'll be 2. 6 faces are there. So 12 K for diagonal, it will be positive. Minus Q, L root 2. Diagonally opposite corner. How many such interactions will be there? Example 1, 6, 3, 8. 4, 5 and 2, 7. So there'll be 4 interactions will be there. So K minus Q, one will be positive, other will be negative by. So this will be L root 3. So what do we get is K Q square L, take it outside. This will be minus 12 plus 12 root 2 minus 4 by root 3. Check the value. This is the initial interaction potential when I released. I'll check the value of UI. If it turns up negative, system will shrink. If it comes positive, system will expand. Is that okay? So you can simplify. So you do get some set of questions where many point charges are there. Do identify, categorize the type of interactions that will be sufficient. Anybody value of this? Minus 12, 12 root 2. 5.8, I think we'll end up with 5.8 nearest value. So this will be minus 5.8 K Q square L. So I got the negative value. So what I should interpret? UI, I'll write it here, minus 5.8 K Q square L. So what do the negative sign? The system will shrink. So negative sign indicates system shrinks. Okay, fine. No. But what is our question? Our question was something calculate velocity. So what happens to the arrangement? Shrinks. What happens to arrangement? Does it the cube shape shrink or expand? So it will shrink. It will not expand. Then after this, Calculate velocity of each charge when the side length of the cube changes from L to NL. And the mass of each point charge is M. How to get the speed? How it is possible? How to get speed of each point charge? That too is telling each point charge. Okay, let's do one thing. We'll take the center of mass idea. What is the net electrostatic force? Is the mutual force, no? So what is the net force acting on the system? Will be 0. So finally, if they shrink means where do they will meet? At the center of mass of system. So where is the center of mass of system? Center of the cube. So definitely the force acting on each charge will be same. Of course, magnitude will be same, directions will be different. So finally, where all the charge particles will meet? At the center of the cube, at the center of mass of the cube. So definitely what happen? You look at the displacement of all will be same. So therefore what happen? All will have same speed. How to bring that answer? I'll go for next kinetic energy one. So shall we go for the same thing? Ui plus ki equal to uf plus kf. Initial interaction potential, that we know it, minus 5.8 kq square L. The release from rest, uf will be minus 5.8 kq square. Shall we write NL only? Because the side length of the cube will shrink from L to NL, plus 8m v square by 2. What is v? Speed of each point charge. Okay, so in a simplified way, we are concluding this particular problem.
Sir, can you repeat why did you take the velocity same for all the particles, sir?
The net force acting on the system. I think I'll justify the statement with the help of some. What is the net electrostatic force acting on the system? Net total is 0, no? Because electrostatics is the mutual force. So where do they meet finally? I'm saying the system will shrink means, if they shrink means where they should meet? They should meet at center of mass. I'll write the explanation here, this part, as the net force, as the net force on system of charges is 0. So, and system shrinks. So what will happen to delta RCM? Will 0. So all the particles will meet at center of mass of system. Then all will undergo same displacement, because that center of mass will be located symmetrically with respect to every point, will be equidistant from every point of charge particle. So in a given time, all are having same displacement. So you look at the speed now.